ICT. So this is a part of the discussion that we had in the HiPEAC Vision. And you could, if you didn't already have it, get the paper version, otherwise you could download it. So just the HiPEAC Vision is one of the deliverables of HiPEAC. So we used to make a new release every 2 years. So starting from this year, we will have a release every year. And the last version is 2021, and we publish it during the IPIG conference in January. So what you could notice is that energy efficiency and sustainable ICT are one of the important recommendations of the IPIG Vision 2021. And we have several articles on this topic, like this one, towards a circular ICT. So this IPIG Vision, we want to make it more easy to read, so it's now organized into articles, so you could pick the article that's where you are interested in. This is one of few articles that are on the topic of ICT, and one of the authors is present here, is Thomas Ernst. So during this session, I will ask each of the panelists to make a short presentation about their topic. So I would like to ask first Thomas Ernst to make his presentation. So normally it's slide up, if I can go up.
Okay, thank you, Marc, for the introduction. So I'm Thomas Ernst from CLAT, and I will present you a few slides on the opportunity to go toward the circular ICT. I think it's a kind of oxymoron today. So we really think about a path for the future from material to components to go into this direction. So, as you know, in the last decade, we had a boom of usage of digital. This includes a boom in internet user, mobile data, internet traffic, and linked also to increase of world population. And this impacts the consumption also of electricity. All electric vision today impact, I think it's a big vision that includes transportation and also electricity network, and we have a fusion between, I would say, the digital world and the energy, electricity, transportation world, and this will impact on also on the environment. So those are all the sectors where digitalization appears, and this includes all sectors, including the network with new energy and renewable energies. So if we want to go toward more sustainable ICT, we need, I think, a very holistic approach. We are still far from circular economy, but we have to work together, including research. So at the research level, how you imagine new computing paradigm, but also new technology, new kind of memories, all using materials, some of them being rare, or and at this time you have to anticipate also end of life and recycling. Here we are more talking about IC architecture. But architecture impact manufacturing also. Most of energy is consumed during manufacturing, and sometimes this is forgotten. And in this holistic approach also you need, as you know, the co-optimization at the design to technology level, but also system technology, and maybe more and more application to technology. Life cycle analysis is also something new in electronics, and we have to develop more and more methods to anticipate the design. Anticipation is a real problem in electronics because, as you know, we do not anticipate usually the evolution in energy efficiency. And if you see the forecast, for instance, the past forecast of energy footprint of data center, and you see, for instance, 6 years ago, an exponential increase of energy was forecast, but in reality, this increase is much lower. So you all work in for higher energy efficiency, and this is usually not included in forecasts. So you all know about the Kuhn's law, for instance, where you have the computation per kilowatt during years, and you see this exponential increase of energy efficiency. So we gain several million of, well, 1/10 of decade of energy efficiency during the history of computing. And so at the end of the day, what counts is really the balance between energy efficiency and uses of digital, because in the future you see this new application like crypto or Bitcoin and or 3D and human-machine interaction will consume a lot of data, and streaming, of course, this is always increasing. And this is plotted here, where you have the this anticipation of consumption for this new application, which increased a lot on the consumption of energy linked to cryptocurrency, for instance, is huge. And we need research also to make them much more effective in terms of energy, if it's possible, or restrain the application. Some people, think that this electricity demand will increase a lot in the future. When you say where go the energy, globally, half is consumed during the manufacturing of the devices, and half during the manufacturing, and half during the use of the device. So manufacturing should be also considered. Another aspect is critical material. Today we're developing new memories, a lot of new architecture or new functionality that require new material for their properties. So today we need in electronic most of the existing material, non-radioactive materials. Those materials are in a few countries, and for instance, China is producing more of rare earth materials and controls also a lot of mining in Africa. So the control of material is a way also to control the whole electronics. So those material will be the black gold of this century, probably. So towards sustainable electronic, we have to envisage, we have to anticipate the impact from the production. So at the production level, reduced waste and water. You heard about TSMC problem that reduce production of IC due to water leakage in Taiwan. Recycling also and end of life should be anticipated. Reduce critical material we can substitute, but what we do more and more is to reduce the quantity of material. When you replace a substrate by an atomic layer, for instance, reduce by order of magnitude the quantity of material. So you all know about what's possible at the IC design level, how we can reduce or increase the energy efficiency by having like we've seen just before, adapted design for the application and adapted accelerator, and also develop ultra-low power expertise. At the project level, we have to make life cycle analysis and try to extend the lifetime. Application also, it's a lot of, I think many progress should be done at the application level. To reduce the data flow and to think about also data lifetime and think about the impact of the application. End of life also today is a big problem for those electronic devices. So we have to anticipate it. To conclude, most of us are working on hardware today and software. So I think we should capitalize on all advances and new concepts to increase the energy efficiency and try to master this global digitalization and its global impact. Thank you for your attention.
So thank you, Thomas, for this introduction about the global challenge. The global challenge. But as you know, this Computing System Week is done in collaboration with the GDR, the Groupement de Recherche SOC 2. And you will have a presentation about what the GDR also think about this topic and a sustainable system on chip. So introduce yourself quickly. And
Thanks a lot, Marc. So welcome everyone. So my name is Alberto Bosio. I'm from the École centrale de Lyon. So I'm part of the, let's say, the local organization team of this event. I'm here to represent the GDR. I'm not really involved in this, let's say, activity about sustainable system on a chip, but I will try to do my best to present what has been done in this sense during the last 2 years in this activity report. So, if you are one of the few people that don't know what is the GDR, GDR is a kind of research group, it's French level, so at national level, federating together different research fields, clearly around ICT, from edge device up to cloud computing, and clearly we target all layers from technological layers up to the software level. So we have all let's say, the expertise. We try to federate all this expertise in this group. So just what is this? This is actually what is called recycle more mount. So it is actually an artist installation where those presidents, you can maybe read here, but if you Google, you can find it in a better resolution actually. So all those presidents were being built using electronic waste, just to sensibilize, let's say, the people that the amount of electronic waste is really huge, and this is just a few fragments, unfortunately. Anyway, so as a okay, it doesn't work. Let me. Maybe it's not the good one.
this one.
This explains why it doesn't work. Thanks a lot. Anyway, sustainable SOC in the context of the GDR. So the context has been already presented, so I don't go through this again. All let's say the motivation behind why we should take in account sustainability during the manufacturing and clearly also the cycle of life of system on a chips. But the point is that what are the initiatives that a research group can actually do? Basically, the idea is to raise a collective awareness of the problem, first of all, because maybe people do not know about this problem. Even myself, yesterday I learned that training a neural network has a carbon footprint equal to 5 cars for the long life. So it is actually a huge carbon footprint. So these things are not really known. even from the expert, I think. So this is really important to raise this awareness. Clearly from all the steps, as it has been said before, so from circuit manufacturing to the usage and clearly to the recycle. We must actually include in the loop academia and industrial actors, because the two have to be actually concerned by these things. And the action that have been taken in the last 2 years are actually in this direction. So we organized a series of seminars and workshops trying to take in account the different aspects about the sustainability. So just to illustrate, okay, it's me that I'm not able to use it. Ah, no, it works. It's me. This is one workshop in 2019 that has been organized clearly by the GDR in the context of the CAS France chapter from the IEEE. So it was given in Bordeaux. So there were keynotes actually about the ICT environmental impact, and also how can we exploit actually ICT to have better use of, for example, soil yield. And then there were a technical poster session just to try to once again raise this awareness for the academia and industrial community. Then clearly the industrial point is fundamental. So those are the companies that actually were involved. So you can see the different, let's say, talks that they provided. So industrial peoples are really and indeed involved in this, so they are aware of this, so this is quite good. And I think I conclude with the last one. So this is, let's say, the last event that was held in Rennes in June this year. It was the national event for the GDR SOC 2, so we have this national conference every year in June actually. And there were, it was a full session dedicated to this, and those were the two invited speakers. The first one was not really about, it was not a technical expert, but it was more on how we can sensibilize also the final user, because also how we use ICT systems will impact or not the energy consumption. So it is important that people must know what does it mean seeing a streaming video. So what is the cost in terms of energy consumption and carbon footprint. And also the second speaker, also in this direction, how we can try to go for reducing this environmental footprint of ICT technologies. So with this, I'm done. So thanks a lot for this opportunity.
So to continue on this, I would like to give the floor to Laurent Lefèvre. And he will present us his point of view, and is part of the GDS Eco-Info structure. So you could, yeah, you take the right one.
Okay, thank you, Marc. Yes, Laurent Lefèvre from Inria, working in École Normale Supérieure in Lyon, here, local one, and also member of a French group from CNRS called Eco-Info, and we'll say a few words just after. It's great that you put me the third speaker, because I will address some parts of Thomas and also the second speaker here. It's not moving at all. Did I took the right?
Normally, yes.
Oh yes, okay, I have to press. Yes, just one step behind, one step on the side. We speak a lot about life cycle of IT and digital products. And this is the life cycle of IT products from mining resources, like presented by Thomas, designing electronic components, mainly in Asia, transporting these IT resources, IT equipment to the customers, so by using maybe a boat like this, or by mainly using airplanes. The step also concerning the using of this IT and the end of life. We call that a life cycle, but it's not really a life cycle. Most of the materials that we take at the end of this workflow don't come back in this cycle. I think it's very rare still now. And also this life cycle has multiple impacts impacts on human. For mining, you can see children working in mines. You can see bad extraction process. The work conditions, of course, in mines, in designing some electronic components. The water consumption that we have all along this workflow here, and which is in competition with human consumption. And of course, we have a lot of impacts on environment. You can imagine the impact on soil and water pollution for mining, but also the impact on resource depletion, biodiversity loss, especially when transporting this amount of equipment in all over the world, with biodiversity mixing, invasive species, and so on. Plus, all around all this bad workflow, which is not very life cycle, we have all the impact on climate with this greenhouse gas emission that happen everywhere in the usage, in the end of life, in the mining, in the designing, in the transport. So these impacts can be very direct on ICT, also indirect with some specific effects I will present later. And a lot of impacts. This is a bad industry for the moment, bad industry. So of course, if we see the shift project numbers with the last report from 2021, ICT is not the biggest consumer. ICT only use maybe 10% of electricity and only generate 3.5% of greenhouse gas. So we have biggest producer, biggest polluter in the world. But the problem with ICT is the percent of increasing per year, 6% of increase per year. So it means a doubling of the impact every 12 years. So if we would like to follow the Paris Accord of Paris from the COP21, we should decrease instead of increasing. So this is the main issue. And as we plan to put everything on electricity, ICT will be a big competitor on electricity usage, and this is a big challenge. Okay, this one, I present it. So this panel here is on sustainable computing, sustainability. I'm not sure to completely know what is sustainability. It's not so clear for me now. What I feel is that sustainability does not only need technological answer, technological reply. It's not enough. Because we need to transform this kind of life cycle, not really life cycle, in something sustainable, and this requires a lot of efforts in terms of research, okay, technological research, but also we need to work in collaboration with humanities and social science. Technology will not be enough to reduce this impact and to change the curve. How can we reduce this impact in every step? This is what Thomas presented on every step. We need to address that, but we need to put some target in terms of reduction of impact, reduction of energy, reduction of environmental impact. And in front of this technological cycle here and workflow, we face some drivers which accelerate this workflow. So the usage, the fashion, for example, accelerates this usage. We need to buy the new smartphone. We want to buy the new computer, maybe because of fashion, because of human reaction. Economy also, when we have some free usage of large video distribution on internet and things like that, economy can increase also the cycle, and we have to fight these acceleration drivers with technology, but also with links with humanities and social aspect. Moreover, we need to take care of some effect, like indirect effect, like for example the rebound effect. Maybe you have learned about rebound effect. If I increase the efficiency of this workflow life cycle, what will be the impact on usage? Do people will use more technology, will buy more technology because it's more efficient, it seems less impacting, less intrusive. So taking care of this rebound effect is a real challenge in digital design. So for example, we did a workshop last year, you can see the slides on this webpage, about rebound effect in digital IT equipments and services. And it's very difficult to measure them and to anticipate them. So, and what does mean sustainable computing? Does it mean carbon neutral computing, like some airlines company say they are carbon neutral, some countries say there will be carbon neutral? What about computing? Is it possible to have a carbon neutral life cycle computing? This will be a next challenge if we want to do that. Of course, we still have the IT for green. Okay, IT can help maybe in some other industrial sectors, other social sectors, but what is the real impact? If we take the full equation in line, it's difficult to measure, to anticipate, and to see the real benefits. So more questions than answers in my slide. One example of trying to put together technological people and also other domain involved people is a groupement de services from CNRS called Eco-Info, created more than 10 years ago and financially supported by INS2I and INE in CNRS. So it's more or less 50 people, 50 members, active group, composed of researchers, teachers, and engineers, so a mix of all these kind of people. And these people are working in computer science, in technology of computing, but also in economy and in human science. And we try to have the full view on this life cycle and try to promote some best practice action to reduce environmental and societal impacts of information and communication technology. The goal for Eco-Info is to bring some services to science and teaching communities in universities, in school, and in research centers. As an example, just a few activities that we did recently among the last years. So one big impact is the adding of environmental criteria for acquiring IT. So most French universities and research institutes in France use the same market for buying IT. It's called Matinfo. This is one of the biggest European markets for buying IT. It's more than 100,000 IT equipments bought every year. And so it's a big impact because universities buy a lot of equipments, research institutes also. With the adding of some Eco-Info members in Matinfo, they propose to have more and more environmental criteria for selecting the electronic resellers, the electronic designers, and this has very big impact. Moreover, they promote to have extended guarantee to extend the lifetime of IT equipments. We also provide some best practice documents. So, for example, managing the electronic waste in universities. For most of universities, it's still difficult to manage the IT equipments at the end of life. So, what to do, how to do, which partners should you use in France for doing that properly. We also propose some tools for estimating impact of IT infrastructures. It's still linked with an initiative in France called Labo 1.5. So we have a tool called EcoDiag, which helps labs to measure and to estimate this impact. We propose a lot of courses for engineers and young researchers, and also some toolkit for teachers in university. More and more teachers involved in some eco-responsibility lessons and courses, sustainability courses, and we provide them some referentials, some toolkit for teaching and for helping them. And also a lot of best practice for eco-designing digital services, which is a big challenge for designers of service in universities and research institutes. Thank you.
So last but not least, I would like to introduce Koen and give you the floor.
Okay, thank you, Marc. So I have a little bit of a different perspective on all this. I agree with everything that has been said, but I would like to point to this graph here. This is the increase of IoT devices counted in billions. And there is a person some of us know, Masayoshi Son, CEO of SoftBank, who still owns, I think, or part of it, of ARM. He said, well, the next 20 years, there will be 1 trillion connected devices in the world and orbiting the planet. 1 trillion, that's billion, that's 1,000 billion. Now, if you think about this, what the impact of it is, so these are the numbers of standby power of a number of devices we all know. So for instance, a charger sockets, some people ask you to remove it if you don't need it because it's consuming power. Even if you don't need connect your device, it's 20 milliwatts. So, but if you go at the bottom, the set-top box, which is switched off, is still using 13 watts. At least That's the table I found on the internet. Now, what's the meaning of this? If you multiply this by 1 trillion, 1 milliwatt comes down to 1 gigawatt, which is a nuclear power plant. So if all the devices that are standby would only consume, like a charger in a socket, 20 milliwatts, and if you have 1 trillion, we need 20 nuclear power plants. If you go down and you look at just a radio or a microwave, this is just 1,000 nuclear power plants. So that's the cost of just only the standby power that we have now in many devices in our homes. This is a smart bulb. It consumes 6.5 watts to produce light, and it also uses 150 milliwatts of standby power, which is the same as around half an hour of light during the day. So if you put this bulb in a room like in your garage where you switch it on only 5 minutes per day, it consumes more standby power than it will consume for producing light. So these are the kinds of things that we should take into account, and very few people think about this. But whenever you replace a mechanical device by an electronic device, you will have power consumption, of course. And I think in my next slide, I have here a nice example. So these are power switches. So these are the traditional power switches that you can buy, just a piece of metal and a piece of plastic. It costs 1.3 euro if you buy them in the shop. On the left, there is a smart switch, which is way more expensive. So it's very good for the company producing this because their margins are higher. But this one is almost impossible to recycle. I mean, there's CMOS devices inside. There are all kinds. It's a very complex device. This is very simple to recycle. You separate plastic from the metal, and there you are. So here we see, and if you use this only to switch on and off the light in the toilet, I mean, this is definitely not very sustainable. This is that one. This one is much better. And this one will last for 50 years. That one might last maybe for 20 years. So this is the kind of considerations we have to make, I think, when we design new systems and when we try to create new markets for new products. So these are the things. But there's something else. So just focusing on power consumption and the carbon footprint of ICT is not what we should do. I think we should look at the complete picture. For instance, if the power consumption of data centers goes up due to the lockdown, but instead we do not fly and travel and meet in person anymore, you will see that globally we will use less power. So we replace the flying and the driving and so on by something which consumes much less power and still allows us to do some of our work. I think meetings are okay. Technical meetings with a few people, I think we all do them virtually nowadays. Of course, networking is much more difficult, but if you do this, it might be better. So many things have been virtualized or digitized over the last few years, like books, movies, etc. And then the question is it better to buy a book on paper like this one, for which you have to cut trees and to print and to ship, etc.? Or is it better to download it from the internet? The answer is, I don't know. There are very few models telling us which one is better for the environment, which one is better for the climate. And I think we also should do research in this area, not only what's the cost of the ICT part, but also what is the global effect of this. Because you replace something else in many cases. So probably Bitcoins are worse than paper money, I don't know. But this is definitely something we should consider. And the last point I would like to make here is people very much like to talk about emissions. And so, well, this is the cost of 5 cars during its life, the lifetime. But we shouldn't do that. Why not? Because it depends on the country. Here you have the numbers in Europe. This is the emissions for, I think, 1 kilowatt hour of electric power. And you see in Poland, it's 724 grams of CO2, but in Sweden, it's almost nothing. So depending on the country where your data center is, there's a huge difference. So if you say, well, this is the equivalent of 5 cars, well, yes, but in which country? And is it an electric car or a car fueled, a diesel car or a big one, small one? So these are not the right comparisons. I think it's much better to focus on power consumption. And then hopefully we will be able to buy the power in the country where it has the lowest impact. So a good idea would be, I think, to move all the data centers of Europe into France, or in Sweden, because there the impact will be the lowest on the climate. So these are my points. Thank you.
Thank you, Koen. So to trigger the discussion that we have in the few moments. Yeah. Do we have it now? Not yet. Up. Yes. Yep. Okay, so we have the presentation. I would like to continue on the balance that was shown by Thomas, the positive and the negative aspects. So first, I would like to go on the negative aspects, and in the negative aspects, I would trigger two discussions. One is indeed the one on energy consumption of ICT and how to cope with it. What could be the practical way to do it, and also how to measure it. So we see that that was a key problem to be able to measure. Well, in IPIG, we were trying to assess what will be the energy consumption from an electronic mail compared to a snail mail or a physical mail. And we did it, I think, 2 years ago, 3 years ago, and we end up with basically 3 or 4 order of magnitude between the optimistic and the pessimistic approach. So first, I would like to have your idea on this energy consumption, how we could measure it and how we could improve it in practice, because we also see that between, let's say, the pessimistic model or the one that didn't really take into account the improvements of the technology that we are all doing in our work. So you see that it's really order of magnitudes between, let's say, the linear interpolation that's translated here into logarithmic on what we physically have now. So what is your point of view? First, from the energy point of view of ICT, how to measure it, how to really have a feedback on what we should do to improve it. So we could use new architecture like computing near memory or in memory, because communicating data is also wasting a lot of energy. Or is it new architecture? Is it new materials? So what is your view? So Laurent, you will okay. Have an idea, because you also have a keynote this afternoon. So.
Speaking of that, yes, this afternoon. I think measuring is a real challenge still now, especially if we want to measure end-to-end. In some distributed and massively distributed scenario, we need to measure, we need to understand very precisely what is the energy consumption. But most of the time you cannot do that because you face some proprietary legacy equipment. So you have more to go in such kind of models where you will do some estimation. What I would like to say also after your presentation, maybe I open it, is that you say if I increase the consumption of a data center, but I don't fly, I don't move. Okay, this is an ideal world that you present, but in reality we don't observe that. We observe more a stacking effect. We increase the data center consumption, but we still fly, we still move, we still use the other impact. If you see the deployment of 5G networks, they don't replace yet now the 4G networks, the 3G networks, and even the 2G networks. If you see the deployment of edge infrastructures, they still don't replace the hyperscale clouds data centers. So everything is stacking. We increase the complexity for good reason, because we need to improve quality of service, performance, latency, new services for IoT. But we are not yet in a transition. We are still now in accumulation. I think it's stacking in English, I'm not sure. Stacking effect. And this is what I would like to see, a transition and not a stacking accumulation and increasing of complexity.
Yeah, I just wanted to show something which is well known, which is the Jevons paradox, that basically say if you improve typically by, let's say, by half the cost, so by energy improvement and things like that, the demand increase more than half. So globally, we will have still more demand, and it's also what we see. We increase the energy density or the energy efficiency of data center of local devices, but their number or their need by, like Thomas showed with the new metaverse with virtual reality and things like that. That's the new brand word triggered by Facebook, also used by NVIDIA. They call it Omniverse, but it's more in the industrial space, and also with all the streaming and things like that. So yes, we have also this problem of adapting, as you say, the efficiency to the demand. So from your point of view, we need more to have a different mindset, or how could we change things? Or
we need to have a full vision of the full equation. And also this graph, does it mean that we should not work on energy efficiency? I'm not sure.
No. It's saying that we should work,
but we should take care of the usage.
Of course. The societal aspects means that, in fact, people are, it's consumed less, it's less expensive,
yes,
so I will use more.
Yes, that's a rebound effect, that's a real challenge, I agree. Yep.
And in view of the measurements, do you have any idea? Because we also see that there is a lot of controversy with the Shift project result. So, what do you think about initiative like the one of the Code Carbon from Joshua Benjo? That's basically where you add one or two lines into your code here for artificial intelligence, and then give it. So perhaps, so you have one remark.
We saw just how expensive cryptocurrencies and Bitcoin mining is. One thing that would be very easy is to ban them. Is anybody thinking of doing that? That way we could actually get hold of the GPUs instead of them all being bought up by people wasting energy and resources doing these things. So are there any moves to ban cryptocurrencies and replace it by something sensible like that?
What I've seen, Simon, is that people are trying to replace the heavy load of the Bitcoin by a challenge that are less energy consuming, but still using this idea of cryptocurrency. It's what they call the green currency. I'm not a specialist, so perhaps one of you know more into this.
I think you open the question of what is a justified usage of IT resource. And this is a big question. You mentioned cryptocurrency, but I don't know, in entertainment and a lot of domains that we could discuss this usage and the impact of this usage. So I think, of course, we can improve Bitcoin consensus and so on to avoid this massive usage of energy, but will it be enough? I'm not sure.
Yeah, Thomas?
Yeah, just to see more in detail this graph, if you see the green curve, there were no increase of global consumption for data center because thanks to this evolution in the architecture and in the energy efficiency. So that means that for some application that can be this balance between usage and improvement of the technologies. And I'm sure that from a more kind of technology improvement, I would say all that we see today, the new kind of memories, the interfacing between memories and computing also, as you know, this is the data transportation is a big problem for energy consumption. Will change maybe the prediction in the future 10 years. So we have to continue to work on this energy efficiency, even if it's not sufficient, because it's difficult to anticipate also the application, but the Gibbons paradox is not always effective, and it's not the case here. And of course, you have also to balance in the gain you have for instance, in automotive. The consumption of the motor was decreased thanks to the embedded electronics. And it's very difficult to have this global balance. I'm sure in the future we'll have an increase of electricity consumption in electronics because you have electronics everywhere, but you have to balance with the gain, and this is very difficult. And we need also a sort of ethics in the use of electronics, and maybe also the end of life, try to find solution, which is very difficult for end of life.
I have a comment on this green curve from the Massanet and Kuhn paper. They also show that data centers providers address the low-hanging fruits. They increase the efficiency of cooling, they increase aggregation in servers. So what was the most impacting and maybe the most easiest aspect to address? What I fear is that this energy improvement for data centers could reach some limit, and we need to go to a next step, and I think the next step is the software. The software wasn't so much addressed in all this improvement. So if we want to add more data centers on this green curve, like edge data centers like we see this morning, we need also to deal with new kind of software, new kind of middleware services that will be deployed in these data centers to continue.
Also the accelerator, as we've seen this morning with Calray, make also the power consumption reduce for so we will have also new generation of accelerator maybe.
I would like here, you know, that the European Commission, at least in this domain of data center, has the idea to move computation to the edge. So making processing more where the data are created on extract information, which is really what is usable from data, and not moving data to thousands of kilometers away, where they are processed. And most of the data are in fact dark data, because either they are not retrieved, so it's write-only data, or they are not indexed and not useful. So what is your view with this new, well, we cannot say that it's new paradigm, but moving computation to the edge more than to the cloud? Of course, I didn't say that we need to forget and stop the cloud, but having more processing at the edge. So do you think it's a good option to be more energy efficient, or is it difficult to assess globally what is the pro and cons of going to the edge? Because of course that will need that you need to have more materials here to build the device. They perhaps, as Kuhn say, the good point of data center is that the computers or the processor are used at their most effective part, and not in low power mode, and not in standby mode, while at the edge they might be more in standby mode. So how do you see do you see that this trend to go to the edge is a good direction, or you see something else, or what is your view on this trend which is pushed by the European Commission now? So Kuhn, yes?
I think it depends on the application. So if you have a lot of data, it obviously makes sense to process it at the edge and then to send the information to the data center. If you don't collect a lot of information, you probably it's probably better to do the calculations at the data center and not invest in local compute power in your edge device. I think in a data center, it's easier to manage, it's easier to recycle, it's easier to control. If you have 1 billion devices out there, how are you going to do the full, going to recycle them? So that's much more difficult. So I think we have to look at the application domain itself and see where it makes sense to do the local processing, where it makes sense to send it to a data center. But I would not think that in one of the documents of the Commission says, well, now we do 80% of the processing in the data center and 20% in the edge. This is going to change 80% in the edge and 20% in the data center. This is not going to happen. It's clear that the data centers are not going to shrink. So if the data centers are becoming 20%, that means that the edge is going to grow exponentially, and that's not something we want. I think that would not be a good idea.
I just want to comment. I agree with you. I think the edge architecture is very challenging and interesting point of view. The problem is also which kind of software we will design for edge. How to program massively a lot of edge infrastructures dealing with millions of end node devices. How do we support resiliency, fault tolerance, but also there will be some competition on energy, on electricity, because we want to design edge architectures close to the users, and the users will be in city, more or less, let's say. So we will need to deploy edge infrastructure in cities. So the computing, competing with some electricity demand in cities, which are already using a lot of energy. So it's a very challenging issue. The pros and cons are not so clear. Do we go to a transition or just a stacking effect, putting edge and fog on top of the rest? But I think we need to care that. But also, like you were mentioning with the guy from Japan saying there will be 1 trillion of IoT equipment, I think we should not follow this kind of announcement also, because if we try to do that, this is an issue. This is an issue. You show it. Yeah.
To go on your point about software, what could be done? Because what we see is that we have an explosion of complexity of software, and to manage it, we create abstraction, layers and layers and layers, which indeed most of the time is adding inefficiencies and bloatware, in fact. So I remember, well, I did it basically just a personal thing. I think in 2000, I was comparing a software which was a formal integration of an equation. At that time, I tested on an old material, so it was a Z80, 4 megahertz using MUMAT, and I tested, I think it was in 2000, under Windows with Mathematica and on a Pentium, I think it was 600 megahertz at that time. And guess what? The Z80 on the MUMAT was faster than the new system using, well, at least between 4 megahertz to 600 was 100 time clock frequency. The memory was from 64K to 1 mega, so again, 1 order of magnitude, but still the raw application, so what I wanted is a formal integration of a system, was faster on the old system due to the bloatware of software and all the layers of Windows. I think it was Windows 95 at that time, plus Mathematica and things like that. So we see that from the core computing, we lost order of magnitudes for the same functionality. So do you see any way where we could have more efficient software in terms of cycle, which indeed cycle for the processor translating energy quite directly? So any idea of how we could overcome this, which was done to manage complexity? Of course, it's a good rationale, but the consequences is that yes, it's lead to more inefficiencies.
Well, if I can just maybe to comment on this, it's like I mean. The complexity is because we have general purpose machines, so we have something that should be able to execute any kind of application. On the other hand, you can see something more like application specific, where you may not have all these full stack of virtualizations. You may go for, again, in the edge devices, you may not have this, so you may be more efficient also from the software point of view. So you don't have this, you have to program in a more efficient way without using this complex stack of softwares. This could be a possibility to go in this direction, to having something efficient. But again, it depends on the application, because this is true for edge devices. You cannot do this for data centers, for example. You need to have this full stack of middleware, virtualization, etc. So.
Okay. I would like to
agree with you. I agree with you. Yes. Having the right language is always a big, difficult question. It depends. I think the most important is to teach the next generation of engineers and the current generation of software developers that resources are not infinite. and we need to take care of the resources they use with their language. So maybe having lower level language, compiled language, a lot of optimization, optimizing technique could help, but teaching this resource awareness, I think it's very important to be more efficient.
So I think that we could stay 2 hours on this topic. So I've prepared a few slides to discuss more on the energy, or what Thomas showed, onto the complexity on the demand into raw materials that increases with the new thing, with the positive effect. But just in view of time, I would like to have your comments on the HiPEAC Vision. Where we basically have all these points, and would like to have your very quickly your view. So first, HiPEAC Vision say that we need perhaps to process data locally with efficient architecture. I think it's what we discuss here. The other point is that we should have more this global view, as we say, because it's not only what your device is consuming for the task, but it's also the energy that is needed for building it. And recycling is not so easy. It's also consume energy. So one other idea what we have is that we need perhaps to change the mindset. So instead of the produce consume, it's triggering me too fast because we are already off time. But going to a new model like the circular economy, I don't know what's happened. I think it's the timing that.
It's a smart system.
Yeah, it's a very smart system that says, okay, you are off time, we need to. So I think the key message that we have is it's time to design differently, to design within limits. So indeed, what you say is how we could change the mindset of people. So do you agree, and do you have some idea on how to bring this awareness both to the research, to the academia, to the researchers? Yeah. So Kuhn?
I think regulation could also help. So if regulation would say, well, for instance, we have regulations for emissions of cars, for electricity consumption of fridges and things like that. So you have all these labels A, B, C, and so on. So for ICT devices, there are fewer. So we have them, I think, for television sets and maybe for some other devices, but not for smartphones, for laptops, for desktop computers, etc. Maybe Europe or anybody else would say, well, this is what is acceptable. And industry, you do whatever you need to do in order to meet these goals. And if you don't meet them, you're either going to pay extra taxes or you're not going to sell your products in Europe. So this can also spur innovation in this area, I think. But now you can do anything you want. If you want to send somebody a birthday or an anniversary card and there's a chip inside which is completely useless because it's used once and then thrown away in the landfill, you say, well, this is forbidden. You cannot sell this in Europe anymore. We don't do this anymore. But we are not yet at that level. But that might help, and that can go very fast. So they can do this next year. That's already thousands, millions of chips that we don't need anymore just to throw away.
So I think it's a little bit, I see that in the presentation of Benoit, you have this robo-taxi that is also for the car industry. They are thinking, because yes, most of the car are most of the time sitting in a parking or not running, which is not efficient for them. So perhaps we need to think about the same for electronic devices. Use them at their maximum efficiency and not putting them idle, or at least when they are idle, they should consume zero, as you say, and not standby power. Yeah, last word.
Yeah, I would say don't forget that half of the consumption, energy consumption, is during production. So the first thing is to reproduce in Europe for me, because the standards are much higher in terms of impact in Europe. So design and produce in Europe first, and then make it sustainable, because we can discuss about sustainability of electronics. If everything is designed elsewhere, it's just a discussion. So that's because the standard, and I agree, the European standard higher and can be higher, and we need production, but also design new architecture to have clients for production, and think about the whole cycle. Then we can think about it because we have at home.
Mm-hmm. So I think now we are already hitting the break session, but I would like still each of you to say one sentence about what is your key element for sustainable electronics. So you just spoke that, so perhaps you could start with saying, what is your key message in one sentence that we should have into this field?
It's
difficult, I know.
It's really difficult. Maybe one point that is not has not been raised before could be, once again, how to sensibilize users. One possibility could be, why don't, as for the network neutrality, so do not prioritize packets transferring over internet, why do not imagine protocols where you can going privileges, for traffic directed to data centers consuming less. So try to doing something like this, and also inform the consumer that, okay, you are using Netflix. Now your counter of CO2 or whatever the metrics you want to use is increasing dynamically. This is not easy, but could be
allowing people to have the choice and be informed about their consumption.
Yeah.
Okay.
So let's not be vague on sustainability. Let's fix some target, very absolute target in terms of factor for impact reduction, and take care of rebound effects.
Okay.
I will go for better models so that we understand what the real impact is, and this can be used then to do all the rest, and then to make the right decisions, because now we're not always making the right decisions because we don't have the correct information.
I would stay on my last sentence. Let's design and produce in Europe and do it in a sustainable way.
Okay, so thank you very much for your participation. As you can see, we could have a lot of discussion on this. We can continue during the lunch break or during a lunch on today. Thank you very much.